having now understood how each of the RNN cells work, vanilla or gated, we can now chain copies of it together for particular tasks. For instance, if I only have one copy, that's just the traditional neural network, traditional feed-forward neural net. Input goes in, one output comes out, time step is equal to 1. If I have a many-to-one relationship, whereby I have a number of inputs up to time t, but I only output once at time t, then this gives rise to models that can be useful, for instance, in the case of sentiment classification. Remember sentiment classification, like reading Twitter posts or Amazon reviews? You read the whole thing and then you say, is it positive, is it negative, what's the score? If you want to generate things over time, then maybe you want a relationship where one input goes in and then that gets fed back in, et cetera, until the end. So asking something like one of these models to write you a short story is something like this, or music generation is another instance. Sometimes you might want to be analyzing a sequence of text, and at every point that you're analyzing, you want to annotate something about that text, right? You're going through a body of text and you're saying, for instance, okay, this is a noun, this is a verb, this is an adjective, this is a whatever, right? And so that could potentially be related to the problem of named entity recognition. So at every time step, you have both an input and an output. There's also other combinations, and this falls under the name sequence-to-sequence models. So if I take something like the sentiment analysis domain and the music generation domain, or the models that were used for these, and put them together, then I get sequence-to-sequence. So you'll see that I have a bunch of XTs that go in, and then at some point, there's just one output, which gets fed in as the initial value for my next model. What is a problem that's useful here? This is machine translation, right? Machine translation was, I'm going to read a sentence in one language in full. I'm not saying anything yet. And then I'm going to generate the target sentence word by word. Amir went to class and then he returned home. I can't pronounce it. Someone who has better French pronunciation can say it. Amir, Alea, and Clav. I'm not even going to try. But translation, right? Hamza, maybe you can, you know French, Hamza, yes?
Yeah.
How do you say the sentence?
I was enjoying this. Amir est allé en classe, puis il est rentré chez lui.
See, good thing I didn't try. Anyway, so right, these two sequences are generated using a sequence-to-sequence model, and they incidentally also have different length, right? So there's nothing stopping us from or forcing us to have the same length sequences. The English one has 9 words, the other one has 11 words. Yes, Jim.
Sorry, a stupid question about the machine translation. How the network after training understand that this time it should output 3 words, or that the other time it should output 5 words, or something like that?
That's a very good question. And my understanding is that language models are trained in a way that they not only are trained on the data that we see within the corpus, the words that we see in the corpus, but in addition to they have some special tokens or some special words that they train on. And one of those special words is, I think, an EOS token, which is like end of sentence or end of sequence. And that's just another dimension that they have in the output probability distribution that they predict. And if so, that's the highest one, and they sample that, and they stop. Now, I think a complementary question to this is, what do we do for different length inputs, right? I could give you 2 sentences to translate, and one is 5 length and one is 15. How do you handle that? I actually don't know. Probably some other, like we have systems that do this, right? So some other clever trick that does this. Maybe, I don't know, maybe a silly one is to say, I'm going to have a maximum length of input, and I'm going to have another special token that just pads, the length 5 sentence with irrelevant information. So it always reads length 15, but it knows at some point that data has stopped after the 15. Maybe this is related to context length that we have in transformers, but I'm not sure. Hamza?
How about just another answer token or start output token, something like that?
Right. And that's another one. it might be the BOS that's here. So maybe like when you're trying to translate, you give your input, your source sentence, and then you just end it with like, all right, your turn. And then the other one kicks off. So like tricks like this can be used. Now, so far, the connections that we've seen were all still also sequential, but there's nothing stopping us from stacking cells on top of one another, right? So I could stack in the variant on the left-hand side called the bidirectional variant. It goes this way and then it goes that way. Or I could just stack a bunch of them in the same direction on top of one another. Why would I want to have like a flipped example in the left-hand side, the bidirectional variant? What's the case where I would want that? Maybe I have a sentence that says, though he later went home, Amir first went to class. Right? Though he later went home, Amir went to class. So the noun, the subject, is occurring after the present. So maybe the bidirectional helps us do that. Vertically stacked, why do we do that? Just like why do we add more layers? Because they're often better at feature extraction as long as our data and our algorithm can scale with it. Yes, Jim.
Sorry, the weights are shared among the stack. But the stacking.
Just extrapolating from what we've talked about in the non-stack cases, where the weights at different time steps between some layer and the ensuing layer were shared, I would think that these ones are shared, then these ones are shared, then these ones are shared, etc., etc. But between the layers, of course, there's different patterns being extracted, so they need not be shared.